At least it's staying there. Okay. All right, 32. This one I'm actually going to talk off topic a little bit about again. Consider a data set of positive values, at least two of which are not equal. Which of the following sample statistics will be changed when each value in the data set is multiplied by a constant whose absolute value is greater than 1? So let's break down the wording part a little bit first. What is it telling us to do to the distribution? One word. Multiply. If I am describing a distribution and I say the mean, that's the what of the distribution. More generic. Center. What kind of measure is this? What kind of measure is this? So these two are dealing with center. This one is dealing with spread. When we are dealing with stuff like that, it breaks down into categories like this. So center gets affected the same way, spread gets affected the same way. This is transforming data. And people get confused sometimes about which one's transforming and which one's combining. So transforming is one data set and do something to every number. Now I'm going to use super easy numbers here to deal with. Let's say we measure everybody's height in the class, and we end up getting our average to be 5 feet. So I'm dealing with easy numbers. Then I want to go back and change everything to inches. What does our new mean? 60 inches. All right, so our first thing there is multiply, which is the same thing as divide, and dealing with center. And then we're going to talk about add and subtract. The one thing about, and I know I'm writing it as center, but I always talk about it usually with mean. Across the entire class, pretty much, mean, what happens to mean is exactly what you would expect to happen to mean. So if I multiply or divide, what would you expect to happen to the mean? Multiply or divide. So we multiplied all of our individual values by 12 to change those to inches. Our center also multiplied, divided by inches. Or by 12 to get inches. Go back, we measured everybody, we were 5 feet tall on average. We went back, the scale was wrong. It was 2 inches short on every single person. We can go back and adjust all of them. What is our new average? Sorry, everybody should have been 2 inches taller. What's our new average?
5'2".
5'2". So what do? Exactly what we would think it would do. We add or subtract to it. So mean always is affected the exact same way you would expect it to. All right, so I've got a distribution. If I multiply it, it's like me stretching it. Didn't get much bigger. What happened to my spread when I multiplied? It multiplied. So that transformation happens how you would expect it to. If I added or subtracted, that's taking this distribution and just sliding it that way. What happened to my spread? When I multiplied or divided, what happened to my shape? From here to here. What was my shape here? Fairly what? What happened to my shape when I multiplied it? So the shape itself is still gonna be the same. And what happens if I just take the distribution and slide it? Shape stays the same. So now we're going back to use this to answer our question. We multiplied or divided, so we are in this column right here. Does our mean change?
Yes.
Does our median change?
Yes.
Does our standard deviation change?
Yes.
And just because I wanted to write these two charts at the same time, I'm going to go ahead and talk about combining, even though it's not part of this problem. So that was transforming data, which means we took one data set and did something to all of them. When we are combining two independent random variables. So like distribution A and distribution B.
Can that be assignments of the meeting?
I am doing this one specific because usually when we do this is the way we deal with it, even though technically what you're asking, the way associating is. I'm just doing these specific. Alright, so I'm taking an entire distribution A, an entire distribution B, and putting them together. So this is my day job, this is my night job, I want to see how much I made together. Mean, again, works exactly how you'd expect it to. This would be mean of A what? Plus mean of B. What about when I subtract them? It's exactly the way you would expect it to. And I know we talked about this one the other day, but I wanted to write it as charts while we were doing the other one. I know I'm going to start with standard deviation A, and I'm going to start with standard deviation B. What am I going to do mathematically right here?
State of variance.
Add them and put in state of variance, which means at the end I have to take it out of the state of variance. So what about here?
The same thing.
The exact same things. Our two rules are state of variance and always add, even if we're subtracting our two distributions. So like I said, I know I wrote this in a different way the other day, but some people like seeing these two charts together. And so that chart didn't have to do with this problem in particular, but I wanted to discuss them together. All right, number 11. I'm going to start this one at a point where I would not expect most of you to start, but it kind of gives you a hint for ways to address some of the problems on the AP exam. If I get a problem like this, I'm going to look at it really quick before I ever read the problem. I obviously have to pick which one's right, but the easiest way to start is what's different. So like, what is something that is changing in those graphs?
Q1, Q4 for real? Or Q2?
Definitely Q2, which is our median. Let's look at what's not changing. So what is the exact same for all of them? The outlier dot, the minimum, and the Q1. So we only now have, so if you can look at it real quick and see that, I can go, okay, I need to focus on the median, maybe the Q3, and where this line should be. just looking at this that it gives us. So it says, hey, if I do this math, this is my math to figure out if it's an outlier or not. This is definitely something the question's asking about. Is this where my line goes to? So this is my cutoff as an outlier. Is this where my line should go to? Okay, give me a wording of where your line should always go to. The last one that's actually in the data set that's not that far. Well, the cutoff would be here. So the last one that's not that far would be somewhere between what and what? 60 and 70? Well, not between 60 and 70. Not between 60 and 70. Yes, yes. E is no, right? If I shifted, I'm good.
Yeah.
Okay, so we're down to C and D before I even really start this problem. But I'm still going to talk about the whole problem even if you didn't do it that way. Alright, so I've got 26. Let's go over 5-number summary. What's the first thing in 5-number summary? Minimum, then Q1, median, Q3, and max. Well, I know where my min and max are. Those are all the same. So let's start with Q. Which one do I do first? Which one of the three things do I find first? Q1, median, or Q3? Median, usually. So I've got 26. So I'm going to split it in half. So how many are in each half?
13.
Alright, so between my 13th and 14th number would be my median. So I'm 6, 10, 16. So my median is somewhere in that bar. If I've got 13 here, then my Q1 is my what number? My what number? What's the, so it's the 7th because it'd be 6 and 6. Or I could do n plus 1, 14 divided by 2, 7. So my 7th number is my Q1. So 6, past that. So my Q1 is somewhere in this bar. Where would my Q3 be?
Somewhere in between Q2 and Q4.
So here it was the 7th number. Here it's going to be the what? The 20th number. 13 plus 7. So my 20th number, or I could go backwards 7. 1, 2, 3, 4, 5. Somewhere in this bar. And these three things right here will get you exactly to your answer. I'm going to have to clear everything and then shift it. So my Q1 had to be between what and what?
10 and 20.
10 and 20. Well, we already said all the Q1s are the same. My Q2 had to be between what and what?
20 and 30.
So that one's not. 20 and 30, 20 and 30. That one's not. My Q4, which we'd already narrowed down between here and here, but my Q3 has to be between
40 and 50.
40 and 50, nope. Yes, yes. We've already checked where this one had to be and narrowed it down to between C and E, or C and D, so D ends up being our answer. And either direction you chose to start there, you're going to end up with the same answer. All right, number 40. Oh, I wanted to go back to one out of curiosity. I think I deleted the problem now. This problem said, consider a set of positive values, at least two of which are not equal. Why did it say that?
So you know that there's a range.
What happens if every single one of them were 0 or were the same number? There's no range and what?
The mean and the median are same.
Which means which of these three? Would be,
0.
so what happens if I multiply 0 by something?
It wouldn't.
And that's why they had to say that. Which kind of comes down to that too, making sure that I'm saying that it gets bigger directly, because of those two things together. I just kind of wanted y'all to see if y'all understood that part of it. Okay, so this one says, which is our best one here? We are dealing with two different things. It tells us that the true value of the parameter is 0. So if that's our parameter, what do we want to do in relation to that parameter? So we want, visually, we want our what to be where? Center to be at 0. This one, the center, that looks definitely at 0. This one, the center, maybe not perfect, but that center looks decent. Might write okay. Here, I'd probably say that center does not look good, but I'm not real sure. Here, center is definitely not at 0. Here, the center is definitely not at 0. So I've looked at the center for each one. What's the other thing I want to account for if I'm trying to do a better one?
Spread.
And what kind of spread do I want to be what I call quote unquote better?
No, closer spread.
A smaller spread. So is this a good spread?
No.
That one's too spread out. Is this a good spread?
Yep.
Not a good spread. Here the spread is good, but the center was bad. Here the spread is good, but the center was bad. So now, which is our best choice? It might not be perfect, but of our answer choices, it is definitely the best one. I probably wrote 2 spread. For which one are you talking about? Yeah, I was just writing those. I should have wrote high spread. High spread is the big one. I had 24. Alright, so we are comparing two different box plots. Without even reading context there, the interquartile ranges are the same for both samples, yes or no?
No.
No. Interquartile range, those are definitely not the same. Range for species B is greater than the range for species A, yes or no? Because the ranges are what? Because range, those are the same for both of them. There are more petal lengths. So if I'm comparing one to the next of a box plot, is it always okay to just say there are more in one than the other? What is a better word choice here? What is a better way to say that when I'm comparing two box plots that I know absolutely nothing about? What do I know about this box right there? So if I just say, tell me about that box, tell me something very descriptive in numbers you can tell me about that box. So what's a better way than saying, straight out more.
There's
A larger percent.
And I want you to, this is outside of this problem, but I want you to understand why this is an issue a lot of the times. So why in this problem am I okay saying more? And keep in mind, I skipped all this on purpose so we can come back to it. So why am I okay in this particular problem saying more instead of higher percent? Based off of wording up here.
Because it's number of petals. Or it's like.
It tells me something. If it hadn't told me that, I would have to say only higher percent and not more. That is not throwing you off on this problem at all, but it is a really good thing to make sure you understand. So like if you're doing a free response and you keep saying there are more of one than the other, they are going to count off if you don't know the sample sizes, and specifically if you don't know the sample sizes are the exact same. Because I could have 100,000 in this group and 10 in this group. I can't say there are more between here and here than there. I can just say higher percent. So now, off of that side note, now that I know I can directly compare these because of the two equal sample size, let's talk about it like percent because it makes more sense. What percent do I know in species A that are greater than 70 millimeters?
Like a little less than 25%.
A little more than 25%, because this is 25%. So a little more. Oh wait, A, yes. Look at the other one. Right. I have that switched right now, right? So it should be, so 70 is here. This is 25%, so I just know that it's less than 25%. B instead is going to be what? More than 25%. Is this one more than this one?
No.
So now I'm going to go here to, it's saying greater than 40. So in species B, what percent is greater than 40? What percent of A is greater than 40? Is this one greater than this one? Is less than 50% greater than more than 50%? And then my last one, I'm talking about less than 30. So in species B, what percent is less than 30? More than 50%. In species A, it's about what? About 25%. There are more that are this than that. Is that one correct?
Yeah.
Your answer is B there. I think that's one of the ones where if people aren't literally writing stuff out like this and thinking through it, you can easily try to do it in your head and write it down wrong. Number 39. I have seen this problem, or a very, very similar problem to this problem, multiple times. And I think the way they word this problem gives you too much direction. I've seen it written to where it's the exact same problem, but they take out a part of it without giving you as much of a hint, and I like that kind of problem better, to be honest. The weights of population of adult male gray whales. So I've got the approximately normal. Here's my mean. Here's my standard deviation. So gray got approximately normal with a mu of 18,000 and a standard deviation of 4,000. And then it talks about humpback whales. It gives me my approximately normal again. Now I have a mean of 30,000 and a standard deviation of 6,000. A certain adult male gray whale, so I'm back in this column again, has a weight of 24,000. So this one value is 24,000. This is where the problem gives me more than I've seen it before. It would be fine if it said a gray male of 24,000 would be the percent of gray males that were under this amount would be under the same amount for what in a humpback male, and not explicitly tell you that. I think that's giving you too much information. So I can switch this one to a z-score. Plug in my numbers, tell me what to write first.
24,000 minus 18,000 divided by 4,000.
Well, 24 minus 18 gives me 6,000. 6 over 4 gives me 1.5. So now it's saying, where would a z of 1.5 be if I now jumped over and went to this distribution? So now I'm starting with my z equals 1.5 and solving for x with a mean of 30,000 and a standard deviation of 6,000. So 6,000 times 1.5 gives me what? What's half of 6,000?
9,000.
3, so it gives me 9,000, so it gives me 39,000. And like I said, I think if you saw that problem, it would not be obvious enough to tell you in between that you should do a z-score. Yes.
The previous column, you don't wanna like, if there's just a larger space.
Are you talking about this one?
If there's a larger space, it doesn't mean there's a higher percentage, it's just whatever that minus marks.
Correct. So like I have basically I can't say any details at all about anything between here and here. The only thing I can say is I know that this is 25, so I know that this is less than 25 and this is more than 25, but I can't say anything about like the difference between. If they ask me something about this number versus this number, I have no information to get me any more detail in between the gaps. Yes. To answer your question shortly, yes. Number 6. I'm going to answer this question by not answering the question at all. I'm going to talk about the answer choices. We're talking about a coin flip, and there are 5 of them. So let's kind of use that to talk through these. C, what kind of a probability is C? What's the only thing we have that starts with something like this that isn't a fraction? It starts with a number over a number.
Binomial.
So this is a binomial. While we're at it, everybody on your orange sheet, find where it talks about binomial. Just so that we're starting to get used to where things are on the orange. And remember, if we do binomial, we usually do our calculator, but we still need to know this equation. So what's the number that goes there? So our n is 5. Well, that looks good. What number goes here? Which is what? My number of xk, yes, both of those are correct. In context, that's my number of successes. I usually call it x, I know the equation she calls it k. And then the other thing it uses is what? Binomial have an n, an x, and a, what's my p in this problem?
1 over 2.
Now, in this one, the only thing that's different about what they have as this answer choice and your equation for binomial is if I have one success, what number should this be? So they actually wrote it to where they switched these two. But this is a binomial with an n of 5, one success, probability of 1/2. They just switched those two numbers. This is saying I got 1/2 4 times, and then I got 1/2. What kind of probability do you think that is? Think about back to when we used to deal with this one. And so geometric, what's the difference between binomial and geometric? In binomial, we count the successes out of total. What does geometric do?
Successes compared to failures, right?
To an extent, but how many successes do I get? Like,
1.
you get 1, you're doing it until. So this is success, and this is failure. Now, I would need more context there, but trying to relate it back to the problem, this would be like maybe, since it's talking about heads, getting tails 4 times in a row, and then my 5th one being heads. Now, obviously, I could write it different ways to get that exact same thing, but just trying to make association there. If a probability is 0, what does that mean? Never happens. If a probability is 1, what does that mean?
Always happens.
Alright, so now let's actually go back to the problem. A coin is to be flipped 5 times. First 4 flips land heads up. What is probability of heads on the 5th flip of this coin? Does it ask us to find the probability that the first 4 were heads and the 5th being heads?
No.
It said all of this has already happened, so it's only asking what that 5th one is. I don't care what the first 4 was because coin flips are what?
Independent.
And it does not ask what scenario that all of this happened. It's saying, okay, yeah, I'm gonna give you some background knowledge, it doesn't matter. Now, what's the probability that my next one is this? You have about 40?
Yes.
Yeah.